Avinash.
Yeah, my name is Avinash Kumar Singh from Patna. I have done MTech Structure Engineer from Rabindranath Tagore University.
Okay, okay. Sheetal Kumar.
So good evening. I'm Sheetal Kumar Inne. I've completed my MTech in structures. I'm presently working for MGNREG, Mahatma Gandhi
Okay,
Udyog Khatra Yojana. Aregas.
okay. So where your office is?
So I work for Department of Karnataka, sir. Like I'm a government servant,
Government servant.
but
Okay,
not on the permanent basis. Like it's contract basis.
okay, okay. Good, good. Venugopal.
Hello, sir. My name is Venugopal, sir. I have done my BM Tech in Nitten University, Karnataka, and I have opened my own consultancy, sir, in Udupi, Shivara Consultancy.
Okay, Udupi. Okay, nice place. Sulekha.
Yes, sir. My name is Sulekha and I am working in UAE now as in G+4 licensed consultant as a structural engineer, and I
Wo-
graduated in
Okay, working in
yeah, Dubai.
Dubai. So you are joined from there?
Yes.
Okay, great, great. Yes, so good, good to know each other. So I am sharing my screen. Let me know once you can see my screen. Is it visible now?
No, sir. Yes, sir.
Yes,
Okay,
sir. Now it is visible.
okay, good. Good. So basically, under this incoming next few sessions, we are going to conduct underground water tanks like circular, rectangular, above ground like ESR, elevated storage water tank, one STP also. Okay, so these kind of our syllabus for the next few session, under which we are going to touch most of the aspects from the for the structural analysis and design for the water retaining structures. Okay, so I hope you know all the at least basics of StatPro, or maybe you are just started on learning that StatPro. Correct. So I assume that yes. So you have some basic awareness, basic knowledge of StatPro. So with that help, we will conduct our few uh, finite element methods or finite method for analysis for water retaining structures. And apart from that, some softwares, there are some few handy hand calculations method also, so that can be very quickly help us to perform analysis and design of the tanks. Okay, so if I started water retaining structures, let's say, let's consider a tank. So how many types of the tank in terms of the location? So basically we can consider as a underground and above ground. Okay, okay. So basically we have two types, irrespective of size I'm talking. So underground water tank and above ground water tank. So if I consider loading, okay, so how many types of loading will be acting on the tank? So I'm asking you, uh, how many types of how many different types of loads which will be applicable for the tanks, whether it is underground, whether it is above ground. So I'm starting just some basic things. So we will deep dive in once we just cover some these brush up things. Okay.
Sir, hydrostatic load will be there of
Okay.
water.
Okay. Hydrostatic. Okay. And
Seismic load.
seismic loads. Correct. Hydrostatic, seismic. If tank is underground, so then
Then vehicle parking. Soil load,
yes,
sir. Soil load.
soil load
Yes,
will
sir.
be also there. Soil surcharge will be also there. That comes under the vehicle parking, or maybe we can consider that. Okay. And apart from that, any other load that we need to consider if structure is underground?
Earth
Soil
pressure.
pressure.
Which one?
Soil pressure, sir.
Soil pressure. Yes. Yes. Soil pressure. Okay, I'm just giving you example. So if you started excavation on the site, so suddenly you found a total waterlogged area. So what will be you consider for your design of that water tank? Hello, Ajit.
Hello, sir. Hello.
So definitely first you need to consider uplift or buoyancy pressure or by flotation. That also you need to consider for underground water tank. Okay. So if tank is above ground, so only soil pressure will not be there, but majorly critical tank will be considered as a underground because it have many additional loads as compared to the above grade tank. Okay. So quickly I just started. Yeah. So if underground water or above ground water tank subjected to dead load, which is itself weight, yes, sometime we need to consider some live load. So if there is a roof of the tank, so that definitely that roof slab or roof platform, whatever it may be, need to consider for that live load. If it is above ground, definitely we need to consider wind load. If it is a elevated storage water tank, definitely we have to consider wind load. Earthquake load, yes, whether it is above, whether it is underground, we have to consider this earthquake load, that is a seismic load. Fluid load means the water load, and soil load. So these are the main type of loads that we need to consider for analysis of the any water tank. Okay.
Sir, can I ask one doubt?
Yes.
If the underground water tank is very near to the main building structure
Hmm.
and the foundation is above uh, uh, than the underground water tank, in that case, how the loads are to be considered?
Means you are saying that the foundation of the building is very close to water tank, correct?
Yes, yes, yes.
Yes. So what happens? So load of that building will be get dispersed to that foundation to the
Okay.
45-degree, correct?
Okay, angle of repose will be acting.
Yes. So definitely that additional pressure which is coming from the footing, that
Yes.
needs to be considered on the wall. If you not consider, then definitely you will be in trouble.
Oh, oh, oh.
Okay.
So, okay. Perfect, sir.
Yes. So that's why sometime what happens. So if you see the some structural drawing, so you can see some small drawing or small sketch in which we have shown that foundation load will be transferred to that 45° or maybe 35° based on that the angle of repose of that soil. Generally, if we don't know, so maybe if on safer side we can consider as a 45. So if anything comes in between that and area, so we need to consider that pressure, additional pressure to the next structure.
Okay, okay. And then shall we need to consider its horizontal components? So because that will act in a 45°, then again we will have to consider its horizontal components for the designing.
Yes, we have some. It was some empirical formulas, so it's exactly not as a horizontal because it's a linearly varying force. Correct, from the
Yes,
top
yes,
to the bottom, it will be get
yes.
vary. So you cannot directly apply a horizontal component on the wall, but it has some formulas based on that distance between your footing to distance between your wall, depth of that your tank. So based on that, it will be change. Okay.
Okay, okay, sir. Perfect, sir.
Okay, so maybe I can try to give some reference on that. So based on that, you can just
Understand it.
yeah,
Yes,
understand, or maybe you can just calculate some values how that
yes,
pressure can be get calculated. Or if you don't know how to calculate, maybe you can do some assumptions like you can consider some additional soil surcharge. So it can take care of that additional pressure which can be transferred through that foundation.
yes. Equivalent load can be considered in a
Equivalent,
surcharge.
yes. Even though if it is there no building near to your wall, suppose your tank is underground and you're next to your wall, suppose there is a heavy vehicle is gets parked, so obviously it will get transferred. So for that also we have to consider some additional load, so that considered as a soil surcharge. So it is up to us, so how much we have to consider, what are the probabilities that in terms of the loading, in terms of the quantity. So it's up to you under that assumptions. Okay, so we can consider or we can take care of that additional unexpected load, and that is a UDL, the soil surcharge that we apply. That is a UDL. It's not like a linearly variable or not as a horizontal component. It's acting laterally on the wall as a UDL, uniformly distributed load.
Yes, yes. And also many times uh, the underground location is near to or over the driveways where the fire attendant is moving. So we also have to consider the fire attendant's load as a moving load for the analysis purpose.
Yes, you have to consider.
Okay. So that will comes under in a moving load.
A moving load not required exactly means I'm not getting moving load means
Uh,
if it is a road you are talking about
yes,
next to the
yeah.
road.
Inside the building campus there are fire driveways.
Mhm.
And if the underground tank is coming in the driveway areas, so
Mhm.
we will have to consider that fire vehicle load, that is around 38 tons something as per the corporation's bylaws and
Mhm.
their fire engines. So based
Mhm.
upon that, shall we consider those load as moving loads or?
No, so same thing, you have to calculate that pressure. Maybe you can calculate separately for the specific fire vehicle, but that needs to be applied to everywhere of the wall. So not exactly at one end or at midpoint, because your vehicle is passing from all entire length of that. Suppose I am considering that. So that load needs to be applied or entire exposed area of the wall, not as a moving.
Okay, okay.
Okay. Okay,
So
maybe it will be
if that
acting at
load is
1 meter, it will be acting at 2 meter, it
if
will
that
be
load
acting
is
at
acting over the top slab, immediately on the top slab.
that will be acting as a gravity load. But I'm talking about that pressure, additional pressure, which will
Okay,
be
okay,
acting out on the wall.
okay, okay, okay.
And moving load, if you're talking about the roof slab, yes, then definitely you need to apply the moving load. But again, moving load will be little bit complicated. But if you want to a little bit simplify that, maybe you can apply the load at the midpoint, because that will be the maximum load.
Yes, that is the worst combination. Yes.
That is the worst combination. Maximum moment will be, maximum force will be at the midspan, which gives maximum bending moment at the somewhere around midspan, and you will get maximum shear force at the support.
Yes. Yes. Perfect, sir. Perfect, sir. Understood, sir.
Okay. So can you quickly please introduce yourself, because I think only you are just remaining.
Yes, I am Ajit Khandagale.
Mhm.
I am B Civil and MTech, and I have the execution experience in the real estate around 13 years.
Mhm.
But now I want to gear up my career in structural engineering as well at the same times.
Okay.
So I have joined this workshop
Okay.
and
Good.
and revising and learning everything right from the scratch,
Mhm.
and also using my experience so that it will be easy for me and it will be beneficial for me.
Yes. Sure. Good. Yeah. So yeah, again we are going back to our loading. So we have just quickly finished this dead load, live load, wind load, earthquake load, and those things. So now in terms of the loading pattern, again I'm asking one question. So which are the governing load combinations for the water tank? I'm specifically asking all of you a question: which load combination will be governing for underground water tank, not above ground? I'm especially talking about the underground.
So it can be dead load plus live load plus earthquake.
No. So you are directly jumping into the load combination. I'm talking about the load case.
Okay,
There will
governing
be
that.
live and water load, sir.
Yes, one side is there is nothing and one side is fully filled.
Little bit close.
One side empty, and means there is no soil on the outer side, and there is only water from the inner side at a full
Yes.
height.
Yes. So yes, almost close. So I can just explain. So if we are designing any water tank, so there are two governing cases. If the tank is underground, because I'm particularly talking most of the time is underground water tank, because for underground we have one additional load, that is from the soil. Okay. Otherwise everything is same for the above. Okay. That's why I'm by default I'm considering underground. So for any water tank, underground any water tank, so there are two cases. Okay. The first one is a tank full and there is a no soil from all over surroundings. Okay. Got it my point? So in that case, there is a no soil from external wall. So what happens? Water pressure will be exert on the wall from inside. Okay. There is a nothing from outside. So that case can be considered as the first case, that is a tank full, no soil. Okay. And what will be the second load case? Tank empty with soil
And
backfill.
yes.
Okay. So that is the governing case. So under that, yes, we can add some load combination like hydrostatic, soil seismic, dead load. But apart from that, first basic two load cases, those are governing is: first is a tank full, no soil; other is with soil, no tank, no water. Okay, got it. So these are the governing load case that we need to consider always. Okay, case one, tank full, no soil backfill. Under that, which load case will be there? So obviously tank full means water pressure will be there. Hydrodynamic load also be possible, correct? Apart from that, no. And sulfate of the tank will be always there, whether it is tank full, empty. Okay, under tank empty, which load case will be there? Soil load, that will be from outside. Construction load, which includes some soil surcharge, vehicular loads, etc., etc. Soil seismic, and last one is a uplift. Why uplift?
Because from groundwater there might be chances of water may lift from the bottom side.
Correct. So we don't want to float our tank due to the uplift pressure if there is a because of the groundwater pressure. Correct. And always we consider uplift check for tank empty case. Okay. Maybe in case of maintenance, we dewatered all the tank, and in that case just we have reduced our water, and just because of that our tank is get uplift. So no, not possible or not desirable. So we need to ensure that our sulfate of the tank should be self-sufficient to resist all the uplift pressure. Okay. Got it?
Yes, sir.
Yes, sir.
Any questions?
Yes, sir. Perfect, sir.
These are some very basic things. I'm just trying to revise all these things. Okay. So now we start with the one design example. Okay. So let's start one underground water tank. This is the plan. Hope you can see my screen. Maybe I will try to this. I hope now it will be better.
Yes, sir. It's visible.
Yes, sir.
Okay. So so we will start from this example. A simple rectangular water tank having inside length of the tank is 12 meter. Okay. Inside width, that is a clear width, is 8 meter. Clear tank height is a 5 meter. And assume maximum water height in this tank is 4.5 meter. Okay, very clear. So if you see the section or elevation, whatever it may be, you can. So we can see this 0.3 meter 2, which is all over the base slab. Okay. And what
Yes.
are the design parameters? So I am assuming my concrete grade is a M25, steel grade Fe 500. Density of the concrete is a 25 kilonewton per cubic meter. Assuming soil density as a 20 kilonewton per meter. Unit weight of the fluid 9.81, but okay, round figure I am considered as a 10 kilonewton per cubic meter. So you got all the parameters or geometry of the design example.
Yes, sir.
Okay. So now I will ask you one question. So suppose if you want to design, how you can design? By hand or by software? If software, by which software?
Stat Pro.
Okay, so you will go with the StatPro.
Yes, sir.
Okay, so before that I will ask you, so do you have any idea about the probable answers? So if you, let's say you are using StatPro, so for what will be the first step? So you will model this entire geometry, correct? You will apply the load, then you will analyze and you will extract the result. But do you know what are the expected answers or results?
So StatPro is only for to check the results, right, sir? Like designing things, we have to do it separately. But using the StatPro, we can find out whether the structure is safe for the certain amount of the parameters what we have used. Design
Yes,
parameters. Is it
yes,
right, sir?
Instead, you can design the concrete also, not only analyze. But my recommendation, generally, what I do,
Yeah.
I just analyze the structure and extract the results, like in terms of the bending moment, shear force, base pressure, what it like those things, and do my design part separately. Like sometime it manually, sometime I have some ready-made by some spreadsheets. So based on that. But my question is like, so if you are using the software first, before that, expected results. So like software is a black box. Okay, so you are feeding inputs and software gives
Yes,
you
sir.
the output. So you should trust, or you should aware, so that outcome is something is related or something close to
Ideal
my
standard.
expected results. So if you don't know it at all, so how you can desire, how you can you depend on that software? Correct. So during your modeling or during your
Right, sir.
application of load, if something is not correct, so obviously stat will give incorrect. And since if you are using stat pro, you cannot say like, oh no, this comes from the stat, because it's a human error. Correct. So my intention is that before using stat, you should thoroughly understand what are the uh, probable results. Like, oh, like for length of the 12 meter, my expected bending moments will be something in the range of the let's say 12 kilonewton meter to 15 kilonewton meter. Expected shear force somewhere in terms of the 12 to 15 kilonewtons. My displacement should be somewhere 3 to 5 mm. And if I go with the geometry, I need to provide some kind of 400 to 500 thick wall. So that should be ready with you. Otherwise, it will be very difficult to compare. If you do without knowing anything and you just throw it to somewhere or your checker, so he will ask you many questions, or maybe he will throw away your design. Okay. So before that, you should know what are the probable answers, probable design, whatever your output. Okay. So don't rely stat or any, not only stat, don't rely on the software. Understand that structure, prepare your expected results, understand your patterns, bending patterns, deflection patterns, how it will be deflect, how that your bending moment will be there, shear force diagram, how it will become. So you, based on that, you can compare your results in the stat. Got it? What I want to say?
Yes, sir.
Yes, sir.
Okay. So now because of that, what you need to do, you have to prepare something without help of the stat. Correct?
Yes, sir.
Yes, sir.
So how you can do that? You
Manual
need to
calculation.
manual
So
calculation.
approx calculation.
Correct. So you have only one option that will be the some manual calculations, and most of the you have know that manual calculation. You have gone through your academics, you have given that paper, so in that you have some questions of 16 marks or say 24 marks. So yes, so but that will be some kind of a tedious things. Okay. So today I will explain you some very quick and unique method of manual calculations. So based on that, you can compare, or not say compare, you can directly submit this. Okay, you can directly complete your design analysis part, not design analysis part of any water tank. Okay, that is a that is method is using by PCA tables. Okay, Portland Concrete Association tables. Do you heard any about this any time before?
No, sir.
No, sir.
Okay, so I will explain you. Okay, but before start of that PCA table, I have to do something as a background preparation. Okay, so for that, what I need to do, I want to calculate all the loadings, correct?
Yes, sir.
So even the loading needs to be done, even though if you are going with the STAD or any software, so you have to calculate, because if you prepared model, so you have to calculate that water load or soil load and you have to apply. So basically you need to be ready with your load calculations. Okay. Okay. So before that, we need to define some geometry also. Next step will be, okay, so loading, yes, that will be also one part. But before that also, we have to fix geometry. Right now, we know all the internal dimensions of the tank. We don't know what is the wall thickness, what is the top slab thickness, what is the base slab thickness. So how you can uh, fix the element thicknesses. Okay, in IS code, we have some guidelines for simply supported beam. We can consider maybe L by 28 or L by 24. If it is a cantilever, we can consider L by 7, I think. So that kind of guidance or reference given. But for the tanks, how we can start? So there are some thumb rules that I always follow. So if I want to calculate wall thickness for my initial go, so I will consider wall thickness as a per 1 feet is equal to 1 inch. So what will be happen? So per 1 meter, or maybe I can go with that. Yes. So if I want to, I will again. So thumb rule is a per 25 mm. That is a 1 inch per 300 mm height of the wall. Okay. So means if I have 300 mm high wall, so what will be my thickness? That thickness will be 25 mm thick wall. So now my question is, so what will be the wall thickness if my water tank height is a 5 meter? Anyone can calculate this?
416.66 mm.
Yes, 41.66 mm. So you got it. How to use this thumb rule? Okay.
Okay.
So basically, we are considering 1 inch per 1 feet, or if you convert into the mm, so per 300 mm, we are considering 25 mm thick wall. Okay. So our wall thickness will be 416.66. So let's say assume a round figure, small d, capital D. So maybe you can consider 500 mm thick, or maybe 400, 450 also. That will be, it's up to you. Okay. So our entire wall thickness is now freeze. So now what will be the next step? So our wall is basically fixed to the base slab. So just add either 50 or 100 mm additional thickness to the base slab. So that will be your base slab thickness. Suppose if you consider 450 or 500 mm wall, so maybe you can consider 550 mm thick base slab. Okay. So why? Because all your bending moment from the wall at the base, that will be get transfer to the base slab. So ideally the same thickness can be also sufficient, but as a safer side, you are adding some 50 or 100 to the base slab. So it will be taken easily. All the bending moments can disperse, or that load can be taken by base slab easily. Understand?
Yes, sir.
Okay. And now top slab. So again, maybe you can consider same thickness minimum same thickness to your wall. Okay. So if my wall thickness comes 500, so maybe you can go with the same thickness of that roof slab also. Okay. So section sizes, yes. So based on that, I am considering wall thickness as a 500 My base slab thickness, I consider additional 100 That's why it comes to the 600 Top slab, I am considering 500 thick. Okay, all good now. So now for our example, we have set our all the element properties in terms of the thickness. Okay.
तो साइज ऑफ द वॉल थिकनेस कैसे लाइक फिर समझाइए तो
Size of
बेस
the wall thickness.
और
Okay.
बेस का ये
So yeah, so thumb rule is that per 300 you can consider 25 thick wall. Okay. So I am asking you one question. So suppose your height of the wall is 600 So in that case, what will be your wall thickness? थ्री हंड्रेड हाइट है
15
तो
15
उसको नहीं, उनको बोलने दीजिए. Who asked that question? So I'm expecting answer from him. किसी ने पूछा था सवाल?
मैंने पूछा था सर अविनाश.
हाँ, अविनाश जी. यस. सो अब मैं थोड़ा क्वेश्चन चेंज करता हूँ. अगर मान लो मेरी वॉल की हाइट 900 है.
यस सर.
तो उस समय मेरे वॉल की थिकनेस क्या होगी?
तो वो तो डिवाइड दे देंगे.
हाँ.
हाइट से.
हाँ. तो कितनी होगी? आप कैसे करेंगे कैलकुलेट?
5000 डिवाइडेड बाय 900
नहीं, आई एम आस्किंग. नहीं, आप क्या कर, आप डोंट गिव द आंसर फॉर दिस. आई एम आस्किंग यू सिंपल क्वेश्चन. ओके. अगर मेरी वॉल की हाइट 300 है तो मैं 25 वॉल थिकनेस ले रहा हूँ. ओके. इसके जगह पे अगर मेरी वॉल की हाइट है 900 900, मेरी हिंदी थोड़ी खराब है. हाँ. तो अगर मेरी वॉल हाइट 900 है तो मेरी वॉल थिकनेस कितनी होगी?
तो 600 से डिवाइड दे देंगे.
600.
सर 325 ले रहे हैं तो 925 से डिवाइड दे देंगे.
हाँ, कीजिए ना. तो कितना आएगा?
ओके. 36.
नहीं, गलत कर रहे हैं कुछ तो आप.
एक मिनट सर. तो 25 आएगा. 300 ले रहे हैं 25 तो 900 ले लेंगे तो 25 आ जाएगा.
900 लेंगे तो भी फिर भी 25 आएगा.
नहीं सर 25 आएगा ना.
कितना?
75.
ओके, 75. करेक्ट. यस, करेक्ट. आपने अभी दे दिया आंसर. मतलब हमने 3 टाइम्स उसको मल्टीप्लाई किया. 25. करेक्ट. 75 आ गया. तो उस हिसाब से अगर 5 मीटर है तो कितना आएगा? आपको आ रहा है, अभी आप कर रहे हैं तो सेम आपको ये भी कर सकते हैं ना.
एक मिनट सर.
हाँ, कोई बात नहीं. अपने पास कैलकुलेटर, पेन बिन सब अपने पास रखिए.
ओके सर. 375 sir.
कितना आ गया?
375.
375?
Yes sir.
नहीं, ये गलत है।
सर
मैं
वो
बताऊं? हाँ,
हाँ तो वो मैंने कर दिया था उससे कि 900 में 75 आ रहा है,
हाँ,
तो उससे मैं फिर उस हिसाब से बता रहा हूँ आपको।
नहीं नहीं, गलत है ना। मैं आपको बताता हूँ, एक्सप्लेन करता हूँ। यहाँ पे आपके पास दो ऑप्शन है। मेरे पास कैलकुलेटर किधर है? पर 300 mm हम कितना ले रहे हैं? 25 mm ले रहे
25 है।
हैं। तो मैं क्या करूंगा, 5 मीटर है। 5 मीटर को मैंने क्या किया, mm में कन्वर्ट किया। मतलब कितना हो गया?
5,000.
5000 mm हो गया।
यस सर।
ठीक है, उसको मैं क्या करता हूँ, डिवाइड करता हूँ 300 mm से। यहाँ पे डिवाइड किधर है? 300 mm। तो कितना हो गया? 16.66।
यस सर।
उतना इसका रेशियो आ रहा है। इसको मैं मल्टीप्लाई क्या करता हूँ, बाय 25 करता हूँ। कितना आएगा?
416।
ये अपना होना चाहिए। तो आप थोड़ा सा देख लीजिए आराम से, कोई बात नहीं।
वो सर मैं
थोड़ा
मल्टीप्लाई, हाँ मैं वहाँ गलती कर रहा था। यस सर।
हाँ, कोई बात नहीं, आप एक बार अच्छे से समझ लीजिए, तो आगे से आपको आ जाएगा, समझ में आ जाएगा, कोई बात नहीं। तो ठीक है, तो अपना वॉल थिकनेस कितना आ गया? 416। लेकिन हम
यस सर।
साइट पे प्रैक्टिकल ऐसा नहीं कर सकते ना। हम अपने मेसन और मिस्त्री को हमसे नहीं बोल सकते कि अरे 416.66 की वॉल बनाओ। तो इसको मैंने क्या किया, राउंड ऑफ किया। चलो भाई
यस
500 mm ले लो और कर दो, हो जाओ शुरू। ठीक है,
यस सर।
ओके। तो ये अपना हो गया सेक्शन साइजेस। उसके बाद अपना क्या फर्स्ट टास्क है कि डोंट गो फॉर एनी एनालिसिस, डोंट गो फॉर एनी डिजाइन, डोंट गो फॉर एनी स्टैट, एनी प्रोग्राम। अपना सबसे पहला, our first step will be to find out whether the entire tank is safe for flotation or not, if it is applicable with the groundwater table. Okay, assume karo कि consider my tank is subjected to full height groundwater table. Okay, means what? Up to the top of the tank, water is there will be a groundwater table. Okay, तो इसमें क्या करना पड़ेगा? So in this case, what we need to do?
Sir, we need to find out the total sulfate of the structure,
Hmm,
and
correct,
we need to see the how much is the uplift pressure. So at least sulfate should compensate the uplift pressure at least, so that we can say that the length and width and thickness is okay,
correct,
can resist the uplift forces.
correct. So what we did, so first we freeze the section sizes which contribute the total sulfate of the structure. Okay, so now what happened? So in our case, the groundwater weight table is up to the top, or maybe say half of the top, but we need to find for that uplift pressure whether sulfate of the structure is sufficient or not. So for that, what we need to do, first we need to calculate entire sulfate of the structure. Okay, and that is very easy. I will not go into that because it's like just addition multiplication things. Okay, so I assume it is simple and you can calculate easily. Okay, agree with me?
Yes, sir.
Yes, sir.
Yeah. So sulfate, let's say maybe 100 kilonewton sulfate is there. Okay, so obviously you have to consider whether that 100 kilonewton is sufficient to uplift force. So if uplift force is 150 kilonewton per meter square, or maybe no, sorry, if I convert into the total force, so if uplift force is a 150 kilonewton, so what will happen? Your tank will be
Rupture, crack,
float.
float.
Yes, correct. So it's not safe. So that's why first task, check your tank is safe or not. So I will go to the next slide. Check the flotation. So based on that, what we always consider factor of safety. Generally, we consider 1.2 to 1.5 as a factor of safety for calculation of the flotation. Okay. Uh, if your tank is not safe, even though after considering this 1.2 or 1.5, what will be the next step? So you need to revise your section sizes, correct? Maybe you can increase little bit your wall thickness. Maybe you can increase your base slab thickness. So you have to little bit play and find out again up unless until your uplift force is less than your self weight, correct? Okay, understand?
Yes, sir.
Okay, how to calculate uplift force? So my base slab is 13.6 meter by 9.6 meter, and my height is a 5.6 meter and 10 is a density. How it comes? Because we have internal dimension of the wall is 12 meter plus my 500 wall thickness, that comes itself 13 meter plus zero point 0.3 toe. Okay, it gives me length of the base slab as a 3.6. Okay, and width, how can calculate? 8 meter is a clear width plus 1 meter both side, 500 that comes to 9 meter plus additional 2.3 that is a zero point 0.6, so it comes as a 9.6. Okay, and water height 5 meter, my clear height of the tank plus 600 cell thickness of the base slab, correct? So that's why the water height below the base slab is 5.6 and density of the water is 10 kilonewton per meter cube. So this gives me total uplift force. This is a very approximate. Maybe you can consider you can consider its volume, and in resisting you can consider some additional weight on the soil if it is. If not, then fine. Okay, during the construction, yes, you cannot consider any soil on the toe. So this way you can calculate the uplift force, and which can be um, compare against the stabilizing force as a self weight. Till now all good?
Yes, sir.
Yes, sir.
So I intentionally added this x, so we have to find out that x value. So it should, we can say it is fail, or maybe we can say it is safe. Okay, I don't know, means I'm just trying to just dump some values there approximately. Maybe at your end, maybe you can calculate self weight, and based on you can find out some uplift force, and find out whether the provided wall thickness are safe or not. Okay, so till now, yes, we have considered this flotation check, we have fixed our geometry, assuming everything is good, provided wall thickness, base slab thickness, top slab thickness are good against flotation during tank empty without soil. Any question? Because now I am going to the PCA table analysis part. So that's why I'm just asking before jumping into that.
So what is it X, sir? That kilonewton
That
per X?
that is the we have to find out that uplift force and self weight.
Okay.
Okay, all good.
Yes, sir.
Okay, so load combinations also maybe we can quickly finish. So generally we have two load combinations. One is service load, under we can consider or we can find out the deflection. We can find whether the bearing pressure of the soil is safe or not for the given safe bearing pressure. Okay, and all the design part, that is the factored load that we need to consider for all element design part, that is considered as a factored load. So generally service load we don't consider any factored, it is. And in factor load combinations, yes, so we need to consider some load factors based on the codal provisions. So I'm just adding as a 1.5D, that's a dead load, plus 1.5 test, plus 1.5 live. Okay, so that is a test condition. Or maybe if we consider some operating case that comes under 1.5D plus 1.2F operating plus 1.5L. Okay, if we consider tank empty, so that is comes under 1.2D, because dead weight is always there whether tank is full or tank is empty. But tank is empty case, in that case you can consider 1.2H. H means H represents for the soil load. Okay, and L means live load. I hope you know this uh, terminologies. D means dead load, L stands for the live, F means fluid load. Okay, and 0.9D plus 1.5, that is for the uplift pressure. Okay, for that design of the base slab, not for the flotation, because flotation that needs to be considered under the service load without any additional factor. Okay, so there is a difference between 0.9D plus 1.5F that applicable for the base slab of the tank, because base slab behavior of the base slab will be totally opposite for uplift. Correct? Okay.
Okay, sir.
Yes. So I hope I am not too fast or too slow. So if you find any difficulty or if you have any questions, you can stop me at any time and you can ask me any questions. Okay. Yeah, and deflection criteria also, generally we considered the deflection criteria as a L by 360. Okay, so means the length divided by 360. So your deflection will be less than this ratio. So in our case, our wall is a 5 meter. So what will be the maximum allowable wall deflection if you consider this L by 360? Can you please tell me? L by 360.
13.88, sir.
13 point. Correct. That is mm. And what will be the allowable deflection for base top slab?
1.38.
Top slab.
Thirty 33.33.
No, incorrect. How you calculate?
12,000 by 360, sir.
Generally, we calculate
Yeah.
deflection at a shorter span. Correct, na?
Okay, sir.
EL by 25.
22.22.
22.22.
Yes, sir.
Correct, correct. So what happened? So if you, that's why I intentionally asked this question. So top slab will be try to deflect in shorter span only. So yeah, there will be some deflection over long span also, but the dominating deflection will be governs for this shorter span. Okay.
Okay.
Okay. So now, yes. So you know how to calculate deflection. Where is that? deflection load combination. Yes. So this way you know how to calculate the deflection. So once you are done, so you have to check whether your wall is safe under deflection criteria or not. If it is safe, so here your assumed wall thickness, slab thickness, base slab thickness is safe. If not, then what will be the next? Any answer on this? Suppose my wall is failing under deflection. The provided 500 mm wall is not safe. So
Increase
how
the thickness.
Revise
in,
thickness.
Increase
in
the depth.
okay, any another load? Any another solution?
So we have to curtail the
Buttresses.
span. We can use it some stiffeners, some
Buttresses.
immediate columns, so that the span will be reduced.
Yes, yes. Okay, good. So no one give me answer that we can
Sir,
increase the
increase the
reinforcement.
grade.
Grade can be possible, yes. But sometimes some students or some people told me that yeah, we can provide increase the reinforcement, but for deflection there is a nothing between the reinforcement. Okay, because it's based on the section modulus of the wall, and because WL's cube by 380 into blah blah blah. So those formulas in that the reinforcement is not taking any part to control the deflection. Okay, so once your deflection ratio criteria get fill, straight away increase the thickness of that member, or maybe you can reduce the span if possible. Like someone told me that buttress, or maybe we can increase some, provide some stiffness like that. Yes. So all
Sir,
good.
how to
Yes.
check the deflection of this one, sir? Beam, sir.
Same thing. Beam length divided by 300.
Then how to check, sir? That's it's correct or wrong, sir?
I'm not understand your
No,
question.
sir. The value,
limit
sir.
for
The
deflection,
how
sir,
can you
he's asking.
understand, sir, that value is under deflection or not crossing the deflection?
Yes. So means now we have the deflection criteria. So you are asking me how to calculate, correct?
No, he's
No, sir. How to
asking the limit,
understand, sir?
sir.
The limit, sir. Limit.
That limit just now you calculated, na? So for wall, it is somewhere 13.33. Okay,
Yes,
let's say
yes, sir.
13 mm. So
Okay.
for wall, if your wall deflect to the 14 mm, 1/4,
Oh,
so
okay,
then
sir.
what happens? So it exceeds your deflection criteria. So it is fail.
Okay.
So maybe you need to increase the wall thickness, or maybe you need to think on that span. So same on the same way, suppose your deflection for the top slab is 25 mm. Okay, so which is more than 22,
Mm.
means it is again failing under deflection.
Okay, sir.
Correct. So
Yes,
in
sir.
that case, you have to again need to revisit, either you can increase the slab thickness.
Okay, sir.
And how to find out the deflection? Okay, that will be the separate thing. If you go
Okay.
with the program, you will ready-made. Once you are done with your analysis part, you will get the deflection. So just check with reference to your deflection criteria whether it is safe or not. If you
Mhm.
are going with some hand calculations, there are some empirical formulas based on the support conditions, whether it is a fixed end, whether it is a pin, whether it is a cantilever. So based on that
Mhm.
calculation of deflection, that formula will get changed. It is not same for everything. It's changed based on the support system. Okay,
Okay.
so till now all good up to
Yes, sir.
deflection criteria, load combinations.
Yes, sir.
Okay, so now we will go to the next part, load calculations, loading on the wall. Okay, case 1. Just like as earlier I mentioned, we have two cases: tank full, there is a no soil from outer side. So in that case, we have to calculate water pressure. Okay. So how to calculate that? So water pressure is always a triangular pressure maximum at base and minimum, or you can say as a 0 at top. Okay, agree?
Yes, sir.
Yes, sir.
Okay, so how to calculate? So in my case, my clear height of the tank is 5 meter. So what will be the pressure? So I am calculating this, or maybe I am considering as a strip. I am consider only 1 meter strip. Out of 12 meter or out of 8 meter wall, I am considering only 1 meter strip. Okay, generally we do the same thing. When we calculate the reinforcement, that is also per 1 meter. When we calculate the shear force, we calculate per 1 meter. When we calculate bending moment, we consider 1 meter. It is the standard, everything, everywhere. Okay. So it's by default, we are considering per 1 meter. That's why on that 1 meter strip, okay. So my water pressure will be 5 meter, that is a height. Okay. 10 kilonewton per cubic meter into 1 meter strip. Width of the strip is 50 kilonewton per meter. That is a triangular force. At base 50, at top 0. That is a for test condition. And what is the operating condition? If my water height is 4.5 meter, during operating case, instead of 50, my water pressure will be 45. Okay, very simple, just multiplication. 5 height into water density. Finish. What is the difference between test condition and operating condition? Anyone can answer?
Sir, operating condition means when everything is a final and now it is filled with water with all supply lines and overflow lines.
Mhm.
So that is the max limit. Up to 4.5 meter we can fill the water into that tank.
Yes, correct, correct. And what is the test?
At the initial stage when we do the execution and construction of the tank.
Yes, yes. So what happened? So what is the test condition means? We poured or we fill the water up to the top of the tank to check whether, because of for that pressure, is there any leakage in my wall? Is there any leakage through that base slab? Okay. So that is the reason that I am checking my structure for full height of the water. And this is a short-term loading. So just for the testing condition, maybe I have constructed my tank, I filled with the water, and maybe for next 7 or maybe for next 15 days, I just monitor from outside because there is no soil. That is the intention. Why we are not putting soil back? Because I want to see, is there any cracks? Is there any seepage? Is there any leakage through wall, slab, through the joint? Okay, that is the intention. Understand?
Yes, sir.
Okay, so that's why. So sometimes we have to consider these two conditions. And why we have to consider two? Maybe some of you can consider thing. No, why we are considering operating? Every time we can just go with the test. But the reason behind this, when we consider the hydrodynamic load like seismic load, so that comes with only operating condition. Okay, you cannot consider test test condition or maybe test height of the water plus hydrodynamic. सो ये केस मैं कभी कंसिडर नहीं कर सकता कि मेरा टैंक का मैं टेस्टिंग कर रहा हूं और तभी अर्थक्वेक हो गया. सो दिस विल बी अ वेरी वेरी रेयर केस. Understand?
Yes, sir.
Yeah, sometime it happen during test conditions also because you never know when it happens. But still, the probability of this combination is very very rare. Okay, that's why most of the time we differentiate test condition and operating condition. All understand?
Yes, sir.
I did one tank design, and during the test condition, a very heavy earthquake was happened. But fortunately, nothing was happened to the tank. Everything was good. Yes, that can be also considered. But even in that case, if there was something happened to the tank, so it's not our fault, because we can't design, or we never design this test condition plus seismic. Okay. Okay. So all good. How to calculate the fluid pressure or operating pressure?
Yes, sir.
Okay. So now next load will be the hydrodynamic. So hydrodynamic loading, I am currently not considering for our syllabus because it needs a separate uh, time. So currently for this syllabus, we are considering only static. We are not considering any hydrodynamic loads. Okay. Now, case 2, tank is empty. Now we want to calculate pressure from the outside. How you can calculate pressure from outside? So what will be the pressure from outside?
Soil pressure.
Soil pressure. How you can calculate?
Unit weight of soil into height of that wall.
Correct. And in addition to that, you have to consider the angle of repose of the soil. Correct. Because similar to water, soil will not act. So either you can consider KO or KA. In our case, all of you know KO and KA.
Yes, sir.
Soil KO means
Coefficient
at
of
rest
pressure.
pressure, at rest
Earth pressure
coefficient.
at rest.
Yes, and Ka means active. If there is a no top slab, then what will happen? Your walls are free. Okay, so in that case, you can consider the active coefficient of soil pressure. If it is at rest, means just because of top slab, your wall at top will not allow freely to move, whether it is in very minor in terms of very but still. Okay, so in that case you can consider the at rest soil coefficient. So in our case we consider Ko is equal to 0.5. Generally it is given by the geotech engineer through it's a geotech report. Okay, if you don't know, maybe you need to some assumptions. Okay, and you can find out the soil pressure. So how to calculate the soil pressure? The formula to calculate soil pressure is Ko or Ka, whether it is in our case Ko into wall height into soil density. So Ko is a 0.5, 5.55 into 20, that comes as a 55 kilonewton per meter. Again, I'm consider 1 meter strip. All good? How to calculate soil pressure?
Yes, sir.
Sir, why 1 meter, sir?
1 meter because I am considering 1 meter strip.
Okay, sir.
Okay. So suppose this is my wall panel. This is elevation, not a slab. Okay. This is elevation. Length of the tank is 12 meter. This length is 12 meter. I am considering any strip because soil will be acting on entire panel, correct? So it will not acting on just only one strip. But for simplicity, for the analysis or maybe as a design, I just consider 1 meter. Okay.
Yes, sir.
So this, if I try to draw a free body diagram, so this is my wall, which is fixed. And because of roof slab, maybe I can consider a pin here. So what happened? This will be the soil load acting from outside, and I will change the color. So this such kind of loading diagram you need to be include in your design report. Whenever you do any analysis design of any structure, you have to prepare a good design report that needs to be submit to next authority. Okay, so this is a water load, this is a soil load. Okay, understand?
Yes, sir.
Okay, now in addition to the soil load, soil pressure, we have to consider some construction load or soil surcharge. Okay, so we already discussed, like Avinash, I think Avinash, no? Avinash mentioned some additional loads due to some fire vehicles, or some additional loads are coming due to the very close footing of the any existing structure to wall. So that all that probability, or that all the possibility that we need to consider while while application of the load on the wall. So now this is the plan. Okay, is oh, and suppose there is a one vehicle is get parked here next to wall. Will load, will, will, will. Okay, so if I try to draw a section here, so what happened? So this is my wall. I'm just, or maybe I will go with the line diagram. So this is my wall. I'm just talking about this wall. This wall fixed, whether it is a cantilever or support, that is fine. But this is my ground level. This is my vehicle or additional load. Because of what happened, because of this load, it will exert some pressure. Correct? Understand?
Yes, sir.
So we have to consider this loading, and this pressure will be depend on the, obviously its weight and this distance. Okay, so if it is close to this, so then definitely pressure will be more. This vehicle gets away from the wall, obviously the pressure will be get reduced. So to consider this, generally what we can consider, some kind of additional surcharge in terms of the soil height. So let's say I am considered 2 meter of the soil surcharge. Like if I consider there is some soil was dumped here next to my wall, this is a 2 meter. यहाँ पे मैंने dump किया है soil. Okay, so this is totally based on your assumption. Someone can go with 1 meter based on the structure, based on the surroundings, whether really any vehicle is coming too close to wall, is there any access, is there any road. If there is a no road, so definitely you don't need to consider anything. But if even though there is a no road, during the construction there might be possibility that some construction vehicles, maybe to supply the sand, to supply the aggregate, to supply the cement, possible. Correct ना? यहाँ पे आ सकता है कोई भी. So to consider that, maybe you can consider 1 meter or 2 meter additional soil surcharge. So that surcharge can be, this pressure can be considered on the wall. And remember, this surcharge will be act as a UDL. And this direction is like this, lateral. And this UDL means it's quite huge as compared to the triangular load. Triangular load, what happened? Maximum at the base, but once you will go above or upward direction, the intensity of the pressure will be get almost zero at the top. But like as against the UDL, you will have uniformly distributed surcharge on the wall, and you can consider on entire wall, entire periphery. So you never know whether your additional heap of soil will be here, your vehicle will be here or here. Okay, you never know. So you have to be prepare for the worst case. What will be the worst case? So you can apply this additional soil surcharge to everywhere. Correct? Got it? Any question?
No, sir.
Okay, then how to calculate that soil surcharge? So in my case, let's say I am assuming only 1 meter of soil. So how to calculate that surcharge? So 1 meter that height, soil surcharge height, 1 meter, KO, that is again coming 0.5, density of the soil 20 into 1 meter strip. So additional soil surcharge will be 10 kilonewton per meter. So if I analyze my wall, so in addition to, maybe again I will delete everything here. I draw line diagram for wall. So this is my wall pressure acting from outside, my support here, plus what will be there? Additional, this is a uniform, correct? So this is 55, 55 kilonewton per meter. This is a 55 kilonewton and this is a 10 kilonewton per meter. So you have to analyze your wall for this combination, surcharge plus triangular soil pressure. And from inside, suppose this is my internal wall, internal face, direction of the force will be like this. This will be, I guess it's 50 for test. Okay.
Yes.
Any doubt before we can conclude, because only 4 minutes and I don't want to just start a new topic that is a PCA table.
Sir, this analysis for the PCA table analysis and the analysis which we got from the approximate methods which we were learned in the during the curriculum, that L by B is less than 2 and greater than 2, then IS code methods. So,
Yes.
so is it very nearer to those methods?
Yes, almost similar. So same thing, like the based on the aspect ratio, we get some coefficients. So
Yes.
based on that, we can ready-madely can calculate the bending moments, shear force,
Yes.
deflections also.
So it will be more convenient and time saving.
Yes, and based on that IS code, it is quite simple also.
Yes. Perfect.
And the main part, like that PC tables, those are irrespective of any units, because those are purely coefficients. So you can use for any units, whether you can go for the kilonewton per meter or maybe SI units or any empirical units.
Yes, yes.
So that is the beauty of that PCA tables. You can, because it's a basically it's an analysis tool. So analysis is irrespective of any design codes.
Yes.
Okay.
Yes.
If you are using IS code, so formula for calculating bending moment WL square by 8 is the same. And if you go with the US or BS code, so again bending moment for simply supported WL square by 8 is the same.
Yes, it will be same.
Correct.
Okay, sir. And sir, design part is based upon the working stress method.
No, nowadays we are using the LSM method.
Okay, okay. Fine, sir.
Okay. So apart from that, any other questions? Maybe we can quickly recap. So from today we started design of tanks. We just covered what are the basic different types, underground and above ground tank. After that, we know which different types of loading that will be applicable on the tank. After that, we identify two basic cases that we always need to be considered for our lifetime. That is a case one, tank full, no soil backfill, and another tank empty, where tank is subjected to only soil load. Okay. After that, what will be the next? So under each case, what are the different load cases are comes? That is a fluid pressure, hydrodynamic pressure, and soil load, construction load, uplift, those things. We started with one example based on some assumed geometrical parameters. After that, by using some thumb rule. Okay. After using this thumb rule, we basically initially freeze the different section sizes of the different elements. Okay. So after fixing that, we checked that sizes are working safe for uplift pressure or not. Okay, if it is good, then we can go with further. If not, then go back, revise your different thicknesses, and again come up with good solution. Okay, like for the flotation. After that, we just gone through how to calculate different types of loading, how to calculate the fluid load, how to calculate soil load, how to calculate the soil surcharge load. Okay, up to this now we have covered in terms of the all design loadings combinations. So based on that, in next session, that is tomorrow, we can directly start on the PCA tables. If you get time, just go through the PCA table. It is readily available on the internet. You can just download as a PDF PCA table for rectangular tank. Okay, Portland Cement Association, PCA. If you don't find, no problem, I will share with you.
Okay, sir. So what is the K0 value, sir, in the next slide?
K0 value is a coefficient of the internal friction of the soil.
Okay, sir.
Okay.
Okay.
That don't call as a K0. It's called as a KO.
KO.
KO and KA.
Okay, sir.
Okay. I think good. We are a little bit exceeding our time, but no problem. Tomorrow again we will meet and we will start on the PCA tables.
Okay, sir.
All good then.
Thank you.
Till
Thank you, sir.
okay. Good night. Yes. Thank you.
Okay.